So, you want to build some software. What do you think is the single most important part? You might guess it's the code itself, right? Well, maybe not. Today, we're diving into the secret first step that all great developers master, the plan. All right, picture this. You've just had that aha moment, a brilliant idea for an app that could literally change everything. You're buzzing with excitement. So where do you actually start? Now, if your gut reaction is to fire up your code editor and just start hammering out functions, I want you to just pause for a second. The most effective starting point isn't what you'd expect. Yep, it all starts with a plan, a clear, logical blueprint. This is the absolute foundation for any successful piece of software. I mean, if you skip this, it's like trying to build a house without any architectural drawings. It's just going to be a mess. And that brings us to the core philosophy behind all great programming. Think first, code later. See, at this stage, it's not about the tools or the fancy languages. It's all about getting into the right mindset. And you know, that mindset really has two sides to the same coin. On one hand, you've got critical thinking. That's your analytical side, breaking the problem down into little, manageable pieces. Then you've got creative thinking, your innovative side, finding new and interesting ways to put all those pieces back together. The real magic happens when you can do both. Okay, so you've done all that thinking. What's the actual thing you create from it? That's your algorithm. And you can really just think of this as the master recipe for your entire program. So what is an algorithm when you get right down to it? It's just a set of instructions, right? But it has to be finite, it has to end, it's got to be step by step, and it has to be totally, completely unambiguous. It's the pure logic of your idea long before you even think about what programming language you're going to use. You know, that recipe analogy is just perfect. An algorithm needs inputs. Those are your ingredients. It has a clear sequence of steps. Those are your cooking instructions. And if you follow them just right, you're guaranteed to get your output, the finished meal. Simple as that. But hold on, not just any old list of instructions counts as a good algorithm. To make sure your recipe is actually going to work, it has to pass a little 5-point quality check. All right, here's that checklist. First up, finiteness. It has to stop eventually. No getting stuck in an infinite loop. Second, definiteness. Every single step has to be super precise. You can't say add some sugar, you have to say add 1 cup. See the difference? Then you need a clearly defined input and a clearly defined output. And finally, effectiveness. This one's cool. Every step has to be so simple you could basically do it with just a pencil and paper. If you nail these 5, your plan is rock solid. Okay, so you've got your algorithm, your recipe, all written out, but sometimes words on a page just don't cut it. How do you actually see the logic? Well, one of the best ways is to draw it out, which brings us to flowcharts. A flowchart is exactly what it sounds like. It's a chart that shows the flow of your program. It's basically a diagram that uses a bunch of standard symbols to map out every single step and every decision. And here's its superpower. It's a universal language. A coder and, say, a project manager can both look at the same flowchart and totally get the logic. No code required. So let's break down the key symbols you'll see. Those ovals? They're your start and end points. Parallelograms are for any time you're getting input or displaying output. The rectangle is the real workhorse. That's for any calculation or process. But the most important one, the real star of the show, is the diamond. This is where your program has to make a choice, a yes or no question that sends the logic down one path or another. Okay, flowcharts are great, but what if you're more of a words person than a pictures person? Don't worry, there's a tool for that too. It's called pseudocode, and it's basically a written sketch of your logic. Here's an awesome way to think about it. If a flowchart is the detailed blueprint an engineer uses, pseudocode is like the simple assembly instructions that come in the box with a new desk. It's not a super technical schematic, it's just a clear step-by-step guide in plain English. Yeah, the name pseudocode literally means fake code, and that's exactly what it is. It lets you write out your program's logic using familiar words like if, else, and while, but, and this is the best part, without having to worry about all the strict rules and syntax of a real programming language. The goal here is just to focus on the logic, nothing else. Let's check out this super simple example, finding which of 2 numbers is bigger. See how those keywords just pop out? You begin, you read the numbers A and B, and then bam, you hit that decision point with if and else. And that little indentation, it makes the whole structure incredibly easy to read. It's simple, it's clear, and it's ready to be translated into pretty much any actual coding language. Okay, so we've got our problem-solving mindset down, and we've got a couple of really powerful tools in our belt. Let's pull it all together and look at the complete programmer's planning toolkit. So when you put them all side by side like this, it all clicks into place, right? The algorithm is your big picture idea, just in plain English. The flowchart helps you see the flow and the connections, and the pseudocode lets you sketch out the structure in a code-like way. Now, the key thing to get here is that these aren't competing tools. They're all part of the same toolkit. You just pick the one or ones that helps you solve the problem in front of you. And this all circles back to the single most important lesson here. A great program, a really solid, elegant piece of software. It isn't just written, it's designed. So I want to leave you with this final thought. This whole method, plan first, then blueprint, then build, is the absolute bedrock of good software development. But really, it's a universal strategy for solving any complex problem. So think about it. Where else in your life, maybe at work, with a hobby, or even a personal project, where could this think first approach make all the difference for you?